This video is about recurrent neural networks. A recurrent neural network, or RNN for short, is a type of artificial neural network that is well suited for processing sequential data. Assume you have some input x that spans over several time steps tau. An RNN now operates over these time steps. At step 0, it receives the initial state S0 and the input x0. It then outputs an updated state S1 and an output Y0. The initial state S0 can be a vector of learnable parameters, or simply initialized to the 0 vector. At step 1, it receives state S1 and input x1. It then computes the updated state S2 and output Y1. It continues to do so for every step t. Internally, the RNN has two learnable functions, g hat to generate the output yt and h hat to generate the updated state st+1. Let's look at an example. Consider that we want to solve the multipath problem of wireless transmission. Given a signal, we wish to filter delayed copies from the signal. To do this online, while the signal is received, we have to remember the current input signal to filter a similar pattern later. An RNN therefore needs to remember a given input for a few time steps and then reproduce it for filtering purposes. Let's assume we are given the following functions g hat and h hat with their respective weight matrices. We start with the first input x0 and initial state S0. We then use g hat and h hat to compute output y0 and state S1. Let us move on to the next input, x1. We now use x1 and the previously computed state S1 as input to compute S2 and y1. We repeat this step until we have processed the complete input. Note that the input signal is stored and passed along in the state. As you can see, we successfully removed the delayed copy from the input signal. Earlier we discussed that neural networks are directed acyclic graphs, DAGs. But RNNs are cyclic, as the state from step t gets fed back to the network in step t+1. How can we train such a network? The solution is to unroll the RNN, in other words copying g hat and h hat for every time step t. This yields one long DAG and we can then sum the calculated gradients for each copy to update the parameters. This is called backpropagation through time. If we look at how the gradient for the earlier layers in the network is computed, we can see that we need to first pass the gradient through all later time steps that follow. Because we are essentially training a network of depth tau, it is very likely that we encounter the issue of vanishing or exploding gradients. For this reason, commonly used RNN cells are made of gated recurrent units, GRUs, or long short-term memories, LSTMs, which address the issue of insatiable gradients in their definition of g hat and h hat. This concludes recurrent neural networks. Thanks for watching this video.